Good day, folks. This is video number 22 for the motion design application, which is in the 3D Experiences platform. It belongs to the dynamics problems that are done with motion design. And in this particular problem, in this particular video, I want to simulate or solve the problem that you see in front of you using motion design. So basically, we have a ladder that's leaning against the wall and standing on a floor, frictionless. Both of them are frictionless, and the ladder is let go at a certain initial angle, 10 degrees, for example. What we like to do is to simulate this. It's going to fall under weight of the gravity, under acceleration of gravity, and we want to simulate this thing and find out at what location does the ladder, the top point of the ladder, actually leave the wall, if it does at all. This problem can be solved analytically in several sources, but this particular one, the complete solution, you can find it there in that reference. And as I said, the objective is to find out at what angle does it leave the wall. Of course, the answer depends on the initial release angle, theta or not. And in fact, in that reference, it is shown that if your initial angle is theta naught, leaning angle is theta naught, then the angle that leaves the wall, which means the normal actually reaction force becomes 0, that N1 on the top becomes 0, is at this particular angle. So for 10 degrees, it's approximately 49 degrees. So when that angle becomes approximately 49 degrees, the tip of the ladder on the top would actually leave the wall. And that height is roughly 0.6, between 0.6, 0.65 and 0.55, something like that range. So we're going to check our answers against this 49-degree angle and this height that you see there. Now, the dimensions are shown here. So leaning against the wall, initial angle 10 degrees, and the dimensions, the length of the ball from, I'm using a elongated ellipse, so this is 10, the radius of the tip, because we're going to use contact. You have to solve the problem with contact. You cannot do the joint, although this problem can be kinematically solved using what is called the slide curve joint, which does not exist actually. There is no such a thing as slide curve joint. But there's another joint called the tangency joint. But if you're doing the dynamics problem, you have to do it with contact. And the width of these padded dimensions don't matter, but I'll make it this dimension. And we'll come to that later on. I'll adjust my simulation time so that it goes up to only so many seconds. Because at that point, it leaves the wall and other things will happen. And also the coefficient of sliding friction is set to 0. You see that. And these things don't have an effect, at least in the portion of the model that we're doing. All right, let's go ahead and do that. Okay, we are in the 3D Experience program. I'm going to start with assembly design and first create the wall. So right click, insert 3D part. I'm going to call this thing wall. Wall. And we'll make it yellow. Let me go make the wall. It's just a L-shaped section. The dimensions of it don't really matter as long as the ladder can be drawn there. So let me make this thing actually a use a profile to do this, and I'll dimension it in just a minute. So let me start here. there, there. Okay. Let me dimension something. For example, I'll make this side 1 meter, 1.2 meter. Actually, 1.2 meter. Okay, proportionally did everything bigger. So this is 1.2. This is, who knows, maybe around 1. Yeah, so these sides are just for the sake of illustration. I'll make it what I want it to be 0.05, and the other one doesn't matter. None of these matters, actually. Okay, so let me pad this thing by 0.01. There we are. It's very thin, as you can see. Okay, fine. Good. So let me go ahead here all the way to the top, insert my next piece, insert 3D part. I'm going to call this thing ladder. Ladder, instance name ladder, and make it orange. Okay, good. So to make it, go to part design. On that same vertical plane, I will sketch. I'll use this elongated hole. All right. A couple of things. That dimension, I'll make it 1 meter. All right. This dimension here, based on the slide, it was 0.01 meter. Yep. And that's pretty much it. But while I'm in the ladder, oh, let me exit that and pad it by same value as the other one. Can't remember this level. Click on it. 0.01. Good. Now, while I am in the ladder, I'll make a point here right at the center of that circle. So let me go to, I'm in part design. Good. So let's go to essential point, center of a circle, and I select that circle right there. Good. Go all the way to the top, and let's fix the wall. So we go to engineering connection, fix the wall. It's fixed. And I'm going to bring this ladder and make it lay against that wall. So how do I do this? So let's go to again engineering connections. I'll use a contact here. This is user defined contact, and for contact, one thing I forgot to do was the angle between this ladder and that. I'm going to do that in a minute. So between this face and that face, okay, and we'll bring this ladder down and put it there. See now, another engineering connection, another contact between this face, the bottom, cancel that, not edge. That face. Try it again. Engineering connection, user defined contact between this face and the face here. It's a new one. say okay, and no. There we are. The only thing I haven't done is that angle correctly. So let me go to my ladder where I drew that elongated hole. Okay, so angle, see, select this dimension with that line, that should be 10 degrees. 10 degrees, exit, and suppose go all the way to the top and update. There. Okay, good. These planes, I don't need it, so let me hide them. Very good. We're pretty much done here. So we're going to go to motion design. Immediately a mechanism will be created. All right. Gravity is acting. Notice under gravity 9.81 is down. That's automatic. And then we go to bodies. There is a wall and there is a ladder. If I double click on the ladder, I'll give the information about the mass of the ladder based on properties of steel 1.578. So that's close to this number, 1.56. It's a little bit different because this other one was based on the box, not the round edges, but it's good. And the wall doesn't matter because it's going to be stationary anyways. All right, so what else do we have? If you look at the scenario, the dynamic scenario has been created. Dynamic scenario has been created. I'll leave this number the way it is, and then I'll come back and show you why is it that I don't want to go all the way to 5 seconds. So we say, okay. Now, what I want to do is to create a probe here or a kinematic measurement sensor. Okay, so, but to do that, I need a marker. We're going to do the market first. So I'll go to mechanism, marker, marker associated with this piece, but with the geometry that's going to be picked by me. And I'm going to try to select this point. I think it's okay. That is the point that's selected. If not, you can always go, if you're not sure about that, let me cancel that and try it again. Marker, select this piece. If you're not sure, you can go to the ladder, the part that you made, and select it from the tree, right there. This marker number 2, cancel that. I didn't want it. Let me see, where is this thing? Which one is this? Well, this is the marker number 1. So let's go back and do it. Screw it up. By geometry, and I select that point. There, a point has been created, and then we say, okay. There's one which is actually, if you can see that marker number 1 is somewhere else. This is the one that I just created. Very good. And now we're going to do over here a kinematic measurement. And I'm going to select that marker. We can do it from the tree, marker number 2. And then we say, okay. Good. We are pretty much done here. So actually, if you go to, if you do this, if you click on that preview, you see that the ladder will go down and it hit the ground and it bounce back and all crazy things. Now, I don't want to do that. Oh, forgot the contact. Completely. That's why it went through it. Sorry, contact. So I will select the uh, part here, ladder, and select the wall, contact between these two, and one more thing, a contact right there, and I want the frictionless contact. So let me see. What I did was this: I clicked on contact, go to contact properties, and sliding friction coefficient, make it 0. Okay, now if I preview, it won't go through it. I hope. but it hits the ground and bounces back, etc. So we don't want to do that. What we want to do, this was too much. The 5 seconds that I had here was too much. So what I want to do is the following. I follow this instruction. Go only for 0.8 seconds. Do that. Go only 0.8 second, and expand this thing. Setting for results. I want the time step, every so many steps, 0.005. Okay, all right, and beginning at time 0.65. I believe this is what I had in there. Is it not? 0.7. Okay, I'll make it 0.7. 0.7. And then we say okay. And now if I do this, it won't show me everything. It'll show me all the stuff from the point that I asked for. So up to a certain point. Let's give it time. It's not recording the result. You'll do it at the time that I set, 0.7 right there. You can see this is moving down. And it's going to go slightly past the point of separation. Of course, we don't know that. It stops there. Okay, good, good. So exit that. Now we're going to run it. So this is a preview, it's not a simulation. Simulation, run it, give it time for this thing to finish. It did. Now we select our dynamic step. This is the result. Go to results, animation, play animation, and we can do that. You see that? It recorded only stuff between 0.7 and 0.8 and 0.7. Now, I want to plot some stuff. By the way, if we look at this thing from the front, view from the front, you notice that separation has taken place. You can see that right there. You can see this. See this? This is separated. So where did it separate? Roughly at time point 7-ish. We go further. See, it's not separating. See that? You can see this. Maybe if I zoom in further, you can see it even earlier than that. Even here, there is separation, right? Even here, probably if you separate it, you see some stuff. Okay. Good. So that's why I reduce this time. That's why I reduce the time, because I don't want to see everything. And now we go to results, 2D plot. Okay, just give it a second. What do we want? We want the kinematic measurements. So I want the y coordinate of that probe, of that point. So y coordinate. Notice that up to 0.75, that distance is almost 0.01 the radius of a circle. So no separation has taken place. You can see that. But gradually, the separation becomes bigger. You see that? At 0.77, for example, you can see that there is separation here. Okay. Now, the other thing I want to do is I want to know roughly where. So I also get the plot for the z coordinate of that, the plot. Now, if I don't want to see this y position right there, and at 0.75 is roughly 0.619, right? 0.619-ish, something like 62, and that matches roughly this number. Okay, so that takes care of this tutorial.